Hello, everyone. So thank you for hosting me and thank you for attending to the session. My name is Ghaleb Zekri. I'm a security specialist within VMware, covering EMEA. And we're going to talk today how we build a least privileged security architecture for virtualization and cloud environment. Let's start by a statement made by Gartner. This year will be a transformational year for enterprises from a networking perspective. And this is conclusion basically from a study that Gartner did on high class and big enterprises in the market. And the reason is mainly because we start facing a new type of technology and new type of information system, and we are mainly living in a hyper-connected world. So the behavior of the users changed, the way how we build application changed, the way how we consume infrastructure changed, and mainly we move it from the situation where we have data center hosting applications, hosting data, to the data is the center of the IT, where we consume services in the cloud, in public cloud, or managed cloud, or even in private cloud, where companies and enterprises are restructuring their IT in order to consume services like in a cloud way. And then we're moving to the IoT. The inclusion of IoT is disrupting the whole way how the IT infrastructure should be built. So in that case, we can see here that the security is mainly the component that need to transform. We need to transform in order to adjust and keep the pace with the digital transformation and the move of the application and the data from the data center to outside. So one thing never changes is the purpose of security. Is mainly we need to protect our critical application and critical data in an increasingly changing world of mobile, of cloud, of IoT, and also an increasingly changing world in the threat landscape, in the way how applications are attacked. And this is mainly based on how the user is consuming the application and the data, and how enterprises are structuring their network and compute in order to deliver these applications. So if we take a look on what we are facing today, is mainly a move from an attack or a threat landscape that moved from targeting infrastructures to more targeting application and targeting the data. And the recent announcement about the last attacks and the big announcement of Yahoo or other companies bring more information about what kind of attacks these companies are facing. So they are sophisticated, they are targeted, and they are more hard to detect. So on the other side, this is not VMware. This is a study made every year about the security environment or security market. And you can see how much security vendors exist in only security market. And we can classify them on different type of security vendors. So some of them are mainly targeting the security of the infrastructure, so going from the user, the device, to the network, to the storage, to the application itself. Others are more focusing on governance, risk management, compliance, or it's more analytics solutions to provide more visibility, insight, and correlation mitigation between different information we collect. And mainly we would like to provide here more control on the compute, on the data, and on the network. And all of that is mainly to preserve what we call the cyber hygiene. The cyber hygiene is the main focus today for a CISO, for a CSO, and how to drive their security strategy and how to secure the application and the business is to build mainly these 5 pillars around their cyber hygiene strategy. These pillars are mainly the least privilege, how to implement the least privilege and make sure that every workload or every application or every user stick with the privilege that were dedicated to him in order to do his job. No trust, zero trust. What we call zero trust model or micro-segmentation is make sure we control and we check every exchange, every communication, every traffic going from and to any process or any workload. Encryption. Make sure if in case of data leakage that the data is encrypted and not usable by hackers or by the attacker. Multi-factor authentication without compromising user experience. So we enforce the authentication to get access to a service, and we make sure that the right authentication provide the right access to the right resources. And then patching. So we keep the pace with the vulnerabilities, discovered vulnerabilities or existing vulnerabilities, in providing patches and applying patches in workloads and applications. So this is the 5 pillars for cyber hygiene policy or cyber hygiene for enterprises. You can notice these pillars are not dependent on the infrastructure, are more related to principle, and they are not tied to physical barrier or perimeter. And as you said in the second slide, our IT is not anymore sitting in specific physical locations. And data now is flowing from and to the cloud, to the data center. And sometimes the security team itself is responsible for protecting data that never crossed their infrastructure. So user is in Starbucks cafe, going to a service in a SaaS mode in the cloud, and security guys is responsible for protecting the data coming from the application and going to the user or vice versa. So let's start with how to drill down these 5 pillars on the infrastructure and how to make it consistent and integrated to the infrastructure itself. So from a VMware perspective, we are intending to provide what we call intrinsic security solution. Intrinsic because we need it end-to-end. We need it integrated to the infrastructure, not built on top of the infrastructure. So for users, we have a workspace one that is the experience of the users, of the end users. AirWatch to control and manage devices, different type of devices from laptop to mobile devices, tabs, and even IoT devices. For the network, we have the capabilities, security capabilities of NSX, network and security, embedded in the virtualization environment, and that expand across multiple data center and even the cloud. And on the storage side, we enforced capabilities of encryption on the storage devices, so in storage in hardware, physical devices. And in compute side, we enforce it by app defense. And app defense is doing enforcing the least privilege principle on the compute side, where it's complementing the NSX security capabilities that enforce the control the traffic and the network. So we talked about least privilege, and this is the topic of today. So least privilege, and this is the definition from Jerome Slater from the MIT. It's mainly every program and every privileged users of the system should operate using the least amount of privilege necessary to complete his job, nothing else. And if what does it mean? If we compare this, the IT infrastructure through the time. So the last time where applications are sitting on the same host was the time of mainframe. So the mainframe, we have every component or every application is built in a way that is sitting on the mainframe. And if you compare it to real world, it's like a company hosted on the same building. So for security of this company, it's quite easy to put a bodyguard at the hall, at the entry of the building, and then he's checking everyone is accessing to the building or exiting from the building, and make sure that there is no unknown people or someone who need to go inside without authorizations. Moving forward during the time, we saw that these applications are now distributed. And they are distributed because we need to build the application in a different way. And that makes absolutely sense when we talk about DevOps, when we talk about agile, business agility and agile dev methodologies and so on. The problem is, if we apply the same principle of the bodyguard that we put in the whole of the entry of the building, now we are in a situation where this guy is not able anymore to control everything that goes to every component of this application. And the problem is, we still now, this is how we implemented security. So we built security policy to protect and to implement the least privilege mechanism, but how we enforce it in the infrastructure is mainly dependent and really tied to a control and enforcement point positioned at the perimeter, a specific perimeter. So we made compromise of saying all component having the same trust level sits together in the same zone, and we'll call it DMZ. And from this DMZ, if I need to go another trust level, another DMZ, I'm crossing a security device or a security feature. And then what happened here is not a problem of technology or security vendor or whatever, or skill, lack of skill. It's just because from a network perspective, if I am attacking or targeting the weakness point in a specific zone, I can freely move laterally and spread my infection in the same trust zone. And then by using legitimate traffic, I can go from a zone to another and then exfiltrate data, and I'm doing sophisticated attack. So it's a mix between vulnerability, architecture, and the way how we implement security. On the compute side, we are facing the same issue. So we build application, we host them in workloads. It could be a VM, it could be container, it could be physical bare metal server. But this VM has an operating system with process. And once we install a component of application on this VM or in this machine, we expect that this machine behave only with what we expect from the application. So if it's a web server, it's just delivering web server and connecting to front-end application server and so on. Once we get a compromised machine, what happens is that we compromise the weakest process, or we exploit a vulnerability, and then we go through the operating system to escalate privilege, and then from escalating privilege, we get access to other process, and we initiate different actions and different tasks that we expect from this VM. So back to the principle of least privileged security architecture, what we need is more, for the least privilege, we need to shrink the exposure surface or the attack surface around the app from the network perspective and from the compute perspective. So that means we need to close the security controls, make them the closest to the app from the compute and from the network. And then we can implement the controls that tied with the application, wherever the application is sitting. And by the way, that makes us more comfortable to address any new kind of implementation or technology if the enterprise is adopting public cloud, or if it's the enterprise is going for private cloud, if they are going for containers, if they are going for microservice development, and so on. And then the idea is to align these control from the network and from the compute side to what the application is expected to do. And based on that, we can provide more insight to governance, risk management, and compliance. And then we have data control, network control, and compute control. So the alignment between the infrastructure and the control could be done through a unique property for the cloud and virtualization, which is what we call the hypervisor. The hypervisor is called what we call the Goldilocks zone. Why? Because we are the closest, in the closest position to the application, to the workloads, without being inside the same trust domain of a compromised or attacked workloads. So we have the same or closest visibility that an endpoint control installed inside the host without having the fact that we are not isolated from the attack surface. And we have the same isolation as a dedicated network device, but without having the negative point as we have a lack of visibility on the application. So the hypervisor is, if we compare it to our solar systems, is like the Earth. It's exactly where we can put controls and we can make them the closest to the app without a dependency on the physical infrastructure. So this is how we do it on the network side. So what we did is, if we look at the infrastructure today, we have servers, and we have a data center built with storage, compute, and network. And then on top of this, we build our virtualization layer. So we host the hypervisor on bare metal server. And then we enriched the hypervisor with network capabilities that extend the security capabilities inside the hypervisor and provide these services on-prem or even more in the cloud. So wherever the application will be, if it's a VM hosted on-prem or inside the data center, or it moves from a data center to another, or we move it even more to public cloud or managed cloud, we provide the same level of protection across the whole infrastructure. So we create this abstraction layer to make the application having the same service level wherever they are and completely agnostic from the infrastructure. So that make us able to build a virtual boundary around the application and tie the control for every component on the application. In case of compromising another server in the same domain, in the same physical boundary, we can easily stop the lateral movement or the lateral propagation at the boundary of the application. So completely agnostic from the physical world. And then we can provide this to all our security partners to enforce the controls with advanced security services, like layer 7 inspection, malware inspection, IPS, next generation firewall, and so on. With that, while implementing these services the closest to the VM, we can easily adapt the security level, even if a host or a workload get compromised for the same application. So we can react on that immediately and put it in quarantine in order to protect the other component of the application as well. On the compute side, we build the same principle. but from the compute perspective. So if we look to the virtual machine and workloads, we're going to see mainly processes and operating system. In case of compromission, as we said, then of one process, the attack get to the operating system and spread across different processes. The difference between what we provide in terms of security solution is, instead of going and try to chase the bad behavior or the bad signature or the malware to detect which kind of malware is attacking my compute, we focus more on how the application should behave and how the application should work, and any deviation from this expected behavior is detected as an abnormal behavior and raise it as an alarm. And then we can take action on it without being inside the compromised environment. So how we do it? So we do it by first knowing what we need to protect, which kind of privilege have every process and every component in the application. So we first need to know the application. We start by capturing how the application should behave and how every process in the application should behave from compute and network perspective. And that leads to a situation where I need to have 360-degree on every component, how interact with other components in other workloads. So I don't need only to look at my workload, but also need to know how my process and my component works together. So I need to have the whole view, not a part of it. And then once I have this intended state of behavior, I'm going to detect any deviation. So I detect the deviation, even if it's inside the compute or something it's outside the compute, and I'm detecting it from the hypervisor level. So I know exactly what happened inside the compute side and take action at the hypervisor level. And then when I detect any deviation, I can build my response. And this response will be mainly to alert, block, or take action on the workload, like snapshot or whatever. So capturing the application behavior means for us to build what we call the intended state. So this is how the application guys think of the application and think of every component and how every component should work with others. And then we build what we call the running state. So think about the application guy build a blueprint. This blueprint will be used by different business unit, and this blueprint will be replicated for every business unit. And the data or the behavior of the application could be a little bit different from one business unit to another. Like 3-tier application with a web server, front end, and database. This is the blueprint, and then when we deliver this to business to marketing, it's going to be used in this way, to engineering this way, and so on. So we calculate what we call the running state. And from the running state, we're going to detect any deviation from what we expect. So to go deep in how we build it, we have this capability to know the structure of the application because we integrate with the hypervisor and the vCenter that manage the virtual infrastructure and the cloud infrastructure. And then we can also integrate with other provisioning tools. These provisioning tools could be vRealize automation, could be Puppet, could be all the DevOps tools that provide to application guy the ability to automate deployment of new applications on my infrastructure. And from that point, I'm building what we call the application scope. So application scope, I have my infrastructure, I have 3, 4, 5, 10 VMs working together. They are sitting in different parts in the network. I know the name and the operating system. I know which kind of network traffic could go from and to every VM and every process. And then by integrating with the application automation framework, I specifically know which version for every process and how this process should work inside the VM and how this process should communicate with other processes in other VMs. And from that point, I can complete with what we call the machine learning, because that covers like between 80 and 90% in what the application should behave. So the machine learning complete the rest of 10 or 20%. That's what we call the running state. And then we build what we called manifest. Manifest is the birth certificate for every component of the application, wherever they are sitting on the same workloads or different workloads like microservices and so on. We push this manifest to every hypervisor, every ESXi host. Wherever the application will land, wherever the workloads will land, they're going to get these manifests already provisioned on the hypervisor itself. And then from that point, when we start enforcing the protection, we start detecting any behavior and compare it to these manifests. So, as we said, we have these workloads sitting on hosts, and then we have these manifests provisioned on what we call protected zone, which is mainly the kernel of the hypervisor. And every behavior on the workload side, process running, calls between process, memory tampering, whatever. So we detect it and we send it to the hypervisor and we compare it to the manifest. If it's in the manifest as a known behavior or a known application and then part of the intended state or running state, that's good. If it's a deviation, we can raise these to the management, or we're gonna apply the response that have been configured as a response to this abnormal behavior. So think about anyone who's trying to hook a process and then make it behaving differently, like issuing SSH connection to the database. This process, for example, is not intended to issue SSH communication to the database. But from the same VM, I can have other process can issue SSH to the database for management perspective, for example. So in this case, from a network perspective, I can see only IP addresses connecting from host A to host B or workload A to workload B. So this traffic is allowed because I have SSH allowed. But from the process perspective, this process is not allowed to do SSH, so I'm going to raise it as an alarm or take an action on it. But what kind of action I can take? It's mainly manual or automated actions, and it could be integrated on the hypervisor, like snapshotting the VM, blocking connection, blocking the outbound connections or inbound connection and alarm. And I can integrate with NSX, so from the microsegmentation perspective, and then quarantine the workloads because something is going wrong with this application. So by building this least privilege based on what we know as a good behavior from the application, we can easily link between two teams that are working in digital transformation for the enterprise. These two teams are mainly the security team and the application team. The main problem today in operating security for the enterprise is to know how these applications are built. The legacy, old traditional way how these teams was working together, it was mainly to, okay, I'm developing an application, I'm bringing it to the security team, now it's your stuff. So my problem is your problem, and your problem is your problem. That's the security issue. It's not my stuff. But on the other side, I'm the only one who knows exactly how this application works. So with the solution we provide here with App Defense is linking between the tools that application guys are using to develop and deploy applications like Puppet, Chef, VRA, and so on. And the security team that now have the visibility on the intended state of the application, and then have the ability to build the controls and enforce the security on the hypervisor and the cloud environments. So it's like having a security team that knows about potential threats and what response we have to build on that. And then the application team that understand the application, and both together are working in order to build the least privilege. And then we can do that by capturing and embedding the application knowledge and enabling collaboration to transform security. So that's for mainly for the least privilege. The other component for cyber hygiene are microsegmentation we talked about with NSX, encryption. So we embed the encryption as well in the compute side. So it's a part of hypervisor security capabilities today, or even on the storage side. And then we have these capabilities to provide application control based on app defense. On the other side, on the user side, we talked about the least privilege on the user side. So we have these 3 pillars that we can build to calculate the security posture and the user posture in terms of privilege. So we validate and verify continuously the right of the users, the right of the app, use it on the device, and the right of the device itself if there is any deviation. So we can immediately react on that and exclude the user from the access and propagate these information to the application enforcement side on the NSX side. So with these capabilities integrated to the infrastructure, and that's what we call the intrinsic security capabilities, we can easily bring these capabilities to partners so they have more insight and more visibility on what's happening on the application side. So we can build better governance, better risk management, and we can streamline the compliance as any deviation will be reported. And then we can build the basis for better cyber hygiene that cover the 5 pillars we talked about. So we try as a VMware, as a company, to play a role in a security market in order to go beyond the fact that we need to secure the cloud and the mobility, but to take this advantage of cloud and mobility to secure applications and users. So with that, I'm ending to my presentation. Any question? Yep.
Hi, thanks for the presentation. So the concept of knowing good is not new, and I think we all agree that most people need to make a lot more effort to measure good. And you're doing this with your ability to in this capture phase and then measuring it with app defense. What's your view on integrating the knowledge which is captured there into other enterprise tools such as CMDBs and enterprise architecture tools? Things like ServiceNow or Irwin, how does that knowledge fit in with those tools?
Yeah, so we are we develop security capabilities through app defense or NSX with in mind to have an open platform and an open solutions. So like we did with the NSX, if you are already user to NSX, which is the network and security layer on the virtualization environment, and we integrate with multiple partners to enforce the security with advanced security services, or even more to provide insights to CMDB solutions or to GRC solutions. We are doing the same with app defense. So we start collaborating for the first phase with vendors like Carbon Black for providing insights and collecting information of reputation on process. And we start working with other vendors like QRadar for the integration with CM solutions. And this is the first step, but we have already open API that could be used by our partner to integrate with App Defense and consume these services from information perspective, so like feeds, to build their own analytics of the application or of the infrastructure, or even more, we can get some insight from their side to build the reputations or to build the protection level that we need. And as I said, we already integrate with provisioning tools. So some of them are also connected to provisioning tools like Puppet, Chef, and so on. So we can, by using these provisioning tools, collect information about the application itself, like data classification, for example. We need to know which kind of data is running on these applications, or will be running on this blueprint. So we can consume this information through the open API.
Okay, thank you.
You're welcome. Other question? Nope.
Okay, so thank you very much for the presentation.